So welcome everyone to today's session. My name is Ian Schofield and this is Paras Buva, and we are both solutions architects here on the Amazon partner team. And today we're going to be talking to you about why you'd want to move from a monolithic architecture to a serverless one. We're going to start off by kind of covering just very briefly, like, what is a monolithic architecture? What are some of the limitations? And why would I want to move to serverless? We'll talk about some of the benefits in a serverless architecture. And then we're going to kind of get into what does this transformation process look like? So there's a 5-step method, and we're going to go through these steps. We're going to take a sample application through these 5 steps, and then I'll hand it over to Paras, who's going to show you what this application actually looks like. He went ahead and built it, so he'll show you in the AWS console what the service looks like, what are the services we're using, what are some of the best practices. So with that, we'll kick it off. So who here, by a show of hands, has actually built a serverless application before? Okay, so some. So as cloud is becoming the new normal, there are a lot of trends that are becoming more and more popular. And serverless is one of these trends. And so serverless, just by its name, is really not having to manage or use servers. So there are 3 kind of, I'll call them pillars, that we're going to cover here that really kind of define what serverless is and how you can benefit from it. So the first is the concept of using managed services. So AWS has managed services, so things like Amazon S3, RDS, DynamoDB, and Lambda. And all these services provide functionality that you can use and consume without having to provision any of the underlying infrastructure. So I'm not creating auto-scaling groups. I'm not creating EC2 instances. I'm not creating launch configurations. You can use things like Lambda, where you just define your code, you hand it over to the Lambda service, and they take care of provisioning it and managing it for you. You're not having to worry about kind of capacity management or deploying across multiple availability zones. Across all the AWS services, we have the concept of a shared responsibility model. And this is where we kind of delineate what AWS is responsible for securing, and then what you, as the customer, are responsible for securing. So if we take a look at Amazon EC2, AWS takes care of securing the physical data center. We take care of securing the hypervisor. And then you, as the customer who has root access to that instance, you're responsible for securing the OS. You're responsible for security group rules. You're responsible for continuing to patch that instance. And so there's that shared responsibility model where AWS takes care of some of these pieces, and you, as the customer, take care of some of these pieces. Now, when we look at managed services, there's a difference there in that AWS is taking care of more of these layers. So like with Lambda, AWS is still taking care of the data center. They're still taking care of they're still taking care of the data center, they're still taking care of the hypervisor. But now they're taking care of the OS as well, because you're only worrying about your code. And so this kind of leads into the second point, which is developer productivity. Because you're not having to worry about securing the operating system, you're not provisioning infrastructure, you're not creating auto-scaling groups, you can focus more on what your business is, what differentiates you. And that's your application, that's your code. And so by doing that, you're able to bring things faster to market. You're able to iterate at a much more rapid pace. Third is the ability to scale your application. As your business continues to grow, you want to make sure that your application can continue to grow with it. And scaling is a key part of this, both scaling in and out. And so by taking advantage of these serverless services, a lot of this is taken care of for you. So we take a look at Lambda. We can continue to invoke our functions, and the Lambda service takes care of provisioning those across EC2 instances for us in multiple AZs, and we just don't worry about it. We just continue to invoke our functions, and the Lambda service takes care of it. Same thing with DynamoDB. If we use the auto-scaling that's built into DynamoDB, we can continue to hit our DynamoDB tables, and it can continue to add or remove provision capacity on our behalf. So we know kind of what are the benefits of a serverless application, but for some context, let's talk about where we're coming from. A monolithic application is, by nature, a large, unruly application. So kind of here in the diagram, you see that there are a number of pieces. And all these pieces are very tightly coupled. They're very connected. They're interjoined. So there's not really a lot of physical separation or logical separation between them. And so this can bring about some challenges. So if one of those specific squares, one of those specific parts of our application, we wanted to redeploy it, how do we do that? Or what if one of these specific pieces fails? How do all the other pieces react? Typically, it's not very well. A lot of times, your application kind of has a binary failure state. It either works or it doesn't. Because there's no separation between the components, it kind of has this waterfall effect where it trickles across all the different services. Also, because our application is deployed as a single unit, we don't really have a lot of scaling here. Let's say one service is getting hit much heavier than others. We can't just provision more capacity for that specific service. Our only option is to really just get a bigger box. And even then, that can only take you so far. So your first thought might be, okay, well, Lambda is serverless. Lambda's cool. I have a monolithic application. Let me just put my application inside of a Lambda function. Now, that's not really going to work because a monolithic application is a large, long-running application. A Lambda function is supposed to be a small, short-lived task. So the Lambda service really shines once you've adopted a microservices architecture. Now, who here has heard of microservices? Heard that phrase before? Lots of people. So we've talked about it in a lot of AWS talks, and we're really trying to drive people to adopt these architectures because there's a lot of benefits that come from them. So if we compare these two architectures, we have our monolithic versus our microservices. So we can see that we now have all this separation between these components. And this gives us kind of a lot of flexibility here. So things like being able to write different services in different languages, being able to deploy different services at different times. And also from an organizational construct, your development teams can now operate autonomously. They're able to kind of operate at their own pace instead of having to kind of subscribe to the entire application's development cycle. So as we move into this transformation process, we're going to take our sample application through this. And so we have a live polling application. So Paris is going to show it to you in the second half, but we ask you a series of questions, we ingest those answers, we store them into a database, and then we display them visually back to you. Now, yes, this is not a monolithic by nature application, but it's still representative, it's still kind of tightly coupled, it's still all running on the same EC2 instance, and so it still has some of those same limitations. So to break it apart, we have our web server, we have our app service, our data access service, and our visualization service. It sits behind a load balancer and runs on an EC2 instance, and it's backed by a relational database. Now, as a reminder, there are many customers that run these types of architectures on EC2 instances just fine. But the way our application is built, we have some limitations. So the first is it's hard to scale. We're currently storing state inside of our application. So if our instance were to die, we run the risk of losing all that state. And so because our state is not broken out of our application, it limits our options to be able to scale our application. We can't just horizontally scale and add more nodes. So our only option is to scale up. But even still, that only gets us so far. And so this leads us to our next point is we can't handle component failures. So because our state is stored locally, we run the risk of losing that state. So a common example you'll hear for this is an e-commerce website. So let's say a user is browsing the site, they're going through and adding things to their shopping cart. They go to check out, and all of a sudden their shopping cart is empty. So what has happened is that web server has died. So all that state that was stored locally on that web server is now gone. And so two things there. One, that's a terrible customer experience. And two, most likely they're going to abandon that purchase process. So now you've just lost that sale. So similarly to our application, we're ingesting these votes. We're storing them locally, but we're kind of holding on to them. We're not really storing them very quickly, durably outside of our application. And we eventually kind of lazy write them to our database. And so we run the risk of losing that data. So similarly, if you have another service that is kind of a real-time processing service, and you're not storing those durably outside of your instance or outside of your application, you run the risk of losing all that data that's in flight. Third is we have a very slow deployment process. Because our application is deployed as a single unit, we run the risk of kind of hampering development teams. If they want to push a bug or fix a bug or push a new feature or enhancement, they have to wait for the entire application. They don't have their individual QA/QC processes. They can't do their individual testing and then just push to prod. Also, it limits our options. So things like, what does our change management look like? What does our deployment timeline look like? Do we have blackout dates across our organization? What language is our application written in? All these decisions are now made unilaterally across the organization instead of within your individual development teams that are most likely going to operate at different paces and have their own ways of approaching problems. So how do we get from this monolithic architecture to a microservices and serverless architecture? So now we're going to walk through what this transformation process looks like. So I'm going to cover what the 5 steps are briefly, and then we'll start to walk through our application through this process so you can understand what happens at each one of these steps. So we'll do our initial discovery. we'll start to design our application. So we'll kind of start to construct what we want to use. What are the services we're going to use? How are we going to connect it all together? And then we'll actually start writing our code. We'll define our templates. We'll start kind of refactoring our application. We'll deploy our application. And then based on the lessons learned throughout this process, and then continuing, as we continue to operate our application in production, we'll continue to refine and iterate on this. So our initial step is our discovery. So an application that is monolithic is very large, it's very unruly. So it's kind of hard to really dissect it and pull everything apart. The best way to look at it is, what are the core business functions of this application? So like, if we take a look at our application, we ingest the votes, we store them in a database, we retrieve them from a database, and we display them graphically. And so these loosely map to our components. Now, yes, this is not a large monolithic application that is going to have a very large list. But the same principles do apply. Now, the little caveat here is that most likely, as you go through this process, you're not going to have this clean cookie cutter delineation between your services. And that's okay. And so this is why we do this initial discovery process, because you're going to identify areas where you might need to refactor your code. And this is going to kind of help you define your timeline as you go through this process. So you can start to pull off the individual pieces and say, okay, this is where we want to define our boundaries. This is where we want to define this individual component. We're going to make this a service. And so once we've defined these components, then we can start to identify, what are the requirements. From an infrastructure perspective, things like, where are we going to store our state? What are our compute requirements? Is it compute intensive? Do we need an API? Is it public facing? Is it private facing? What are our storage requirements? Do we have really high I/O requirements, or are we working with media files where you need large sequential storage, security requirements, etc. These are all going to be defined by what your application currently is, as well as your organizational requirements, things like InfoSec and other things. So once we've defined these requirements, we can then start to map those to the AWS resources. So things like, okay, we need a database. So that's naturally going to kind of steer us towards something like RDS or DynamoDB. But this leads to additional decision points. Do we want to stick with a relational model, or do we want to move towards a non-relational model? So those are some decisions that you have to make as an organization. What do you want to shift to? As you begin this transformation process, there are those decision points that now is the time to make them, not when you're halfway through building. Secondly, what are you going to use for your compute? You could use something like Lambda. You can use ECS, which is our container service, or EC2. Yes, this talk is mostly on serverless, but I want to call out that not every application is a perfect fit for the serverless model. That's okay. There are some applications that are a better fit for ECS or EC2. Or there may be some requirements where Lambda just won't fit into that model. So it's important that you kind of evaluate everything evenly depending on what your application is and what your requirements are. So when we take all our pieces, we'll go ahead and map these to our rough architecture. So we're storing our static content in S3. We put CloudFront in front of it, so we're using this for our caching layer to lower our latency and get our content closer to our users. We were able to decompose our application into various Lambda functions, and then we're using API Gateway to invoke those functions. And we have our data that's stored in DynamoDB because most of our data was key value pairs, so it works very well with DynamoDB. So as we come up with this model, the first question is, how do I secure it? It's important as you build your application to think about security, not only while your application is running, but when you're designing it, when you're deploying it, when you're building it, when you're continuing to operate it. And so even though your application is spread across a large number of AWS services, you still have a great security posture. So all the AWS services are built with security in mind. So with CloudFront, we can use origin access identities to be able to control where's our content coming from. We can use things like geo-based restriction to limit who can access our content. With Amazon S3, we can define things like bucket policies and object ACLs to, again, control who has access to our content. Then we can use things like API keys and API gateway to control who has access to it. We can write a custom authorizer and use JOT tokens to control, again, who has access to it. We also have the IAM constructs that we can apply to services like Lambda and DynamoDB. So who can invoke our functions? Who can put an item in our DynamoDB table? In all these things, we can define infrastructure as code. And so a lot of people might have heard this term before. So you can use things like CloudFormation templates to define not only your resources, but also the security constructs around those resources. So we can define things like our bucket policies, our security group rules, everything that you can see here on this diagram. And so we now have security at 2 layers. So we can define who can change these things. So we're storing these templates most likely in code commit or GitHub. So we can control who has access to commit to this repository, who can change a security group rule in a template and recommit that, as well as the actual security constructs themselves that we've defined, like the security group rules or the bucket policies. In addition to security, it's important that you know what's happening within your application. You want to have kind of the visibility into, are things performing well? Are they not performing well? Do I have pain points and friction points? Similarly to security, the AWS services have monitoring functions that are built into it. So things like access logs for S3 and CloudFront. You can see who's accessing those, where are those requests coming from. With CloudTrail, we can monitor all the API calls within our accounts. And that's a good one to have enabled by default, is to be able to store these CloudTrail logs external to your account and have some sort of anomaly detection. A lot of people take these CloudTrail logs and they know they're storing these CloudTrail logs, but they never go through and actually analyze them. They're never looking for, hey, I never work in the US West 2 region, but now I'm seeing EC2 instances get spun up. So by having some alerting or monitoring based on these CloudTrail logs, you can kind of identify things that are happening within your AWS account. We also have the ability to ingest application level metrics. So with CloudWatch, we can look at things that are at the application layer that CloudWatch can't natively see. We also can look at things like the latency and the count of requests in API gateway. Or DynamoDB, we can look at things like throttle requests. With Lambda, we can look at the duration and any errors, but we can also enable X-Ray, which is a tracing service that will allow you to see the relationships between your Lambda functions. So if I have a Lambda function that invokes another Lambda function, I can see and trace those calls as they trace across the Lambda functions. Or if I make calls to external services like SNS or SQS or DynamoDB, I can see what that request looks like, and I can see how that impacted my function's duration. So at this point, we've kind of defined what our resources are, what are the AWS requirements. We kind of have a roadmap for how we're going to deploy this, what are the services that we're going to start to pull away from our monolithic application. But we need to actually start building it. And these steps kind of bleed into each other because we can use frameworks. And frameworks allow us to kind of, again, abstract away some of the actual infrastructure provisioning steps and, again, focus more on our application. So if we're defining something like an API, we're going to use API gateway, and we're going to use Lambda functions. Now, in order for us to create this, you're going to create your API gateway, you're going to create your stage, you're going to create your resources, you're going to create your method, you're going to create your Lambda function. You're also going to create the invoke permission that allows API gateway to invoke that Lambda function. So there's a lot of individual pieces that you have to kind of juggle and keep track of. But really, only one of those pieces is actually really related to your application. So you can use things like frameworks to be able to just say, this is my Lambda function, this is the endpoint I want to hit, you figure it out. And so that's where these frameworks really shine. So we have things like the AWS Serverless application model. We have the Serverless framework, we have, there's Zappa, there's Chalice, and there's many other out there, depending on the language and what you're familiar with. So I want to dive into SAM just a little bit more, because I think it's a pretty powerful tool, and we've used it for a number of projects internally. And so again, it allows you to define your infrastructure as code, and this is because it sits on top of CloudFormation. So CloudFormation is a service that allows you to define your resources, and then it's able to provision those resources. And it's intelligent enough to determine the order in which these resources should be provisioned. So if I'm creating an EC2 instance, it knows it has to create the VPC and the security group first. If I'm tearing my stack down, it knows it has to kill the EC2 instance first before it goes through and kills the security group and the VPC. And it's also smart enough to know the difference between, I've deployed the stack before, I've changed, let's say, a security group rule, I'll only change that resource. So you can continue to incorporate this into your CI/CD pipeline to be able to continue to make changes and use CloudFormation as that executioner to provision and deprovision your resources. And because SAM sits on top of CloudFormation, you're able to use all of your existing CloudFormation templates to continue to operate without having to migrate or change or anything. You just take advantage of the new transforms that are available within SAM. You define your Lambda functions, and you define all your typical resources, and you're able to provision them. So here's the example that I gave previously, where you're defining an API, you're defining a Lambda function in a DynamoDB table. On the left-hand side, we have a CloudFormation template that creates all the resources. So it creates our stage, our resources, our methods, our permissions, our Lambda functions, and our DynamoDB table. Now, you can see there's a lot of lines there. There's a lot of essentially boilerplate code. On the right-hand side, we're creating the exact same thing in SAM, but you can see it's a lot less lines. So this allows you to focus less on the template and more on your application, so saving you time. So we now have our infrastructure as code. We know we can use CloudFormation or any of the other templating services out there. So we can set up our pipeline. And this will allow us to continue to operate at a much faster pace. Now, this example is going to focus mostly on SAM, but the same principles to apply to really any of the frameworks. So on the left-hand side, we have our templates. So this is going to encompass things like Redshift clusters, DynamoDB tables, our Lambda functions, and so on. It'll also include our application code, so the actual deployment package for your Lambda functions. So this is things like your Java, your Node.js, your Python, and so on. And so what we'll do is we'll go ahead, we'll package this up, we'll store it in S3, and so at this point, we have a serverless template that's pointing to these artifacts. So we'll hand this template to the CloudFormation service, and it'll go ahead, it'll kind of decompose this, it'll make those inferences based on what are the resources we need to create. So the serverless framework, or the SAM framework, is able to identify, okay, I have an endpoint, I have a Lambda function, I'll go through and create all those resources for you. And so it spits out a template that CloudFormation then interprets and then deploys on your behalf. And so if we put this all together, this kind of defines our pipeline. So we have our packaging step, we go through and put everything together, we can kind of store this, we can version that in code commit or GitHub, and then we can use something like code pipeline to be able to execute all these various stages. And so we can use code pipeline to kick off our build process, package everything, store it in S3, and then go ahead and deploy it. So at this point, I'm going to pass it over to Paras, who's going to show you kind of nitty-gritty what those details look like, how this application was built, and what the serverless framework can do.
Awesome. All right. Thank you, Ian. That was awesome. So Ian talked about, what are things that you need to think about when you're moving from a monolithic to a microservice application. I have a small demo. So I'd like you all to pull up your smartphones, your laptops. I see many of them have it open, and go to this website, democlub.xyz, right? And in parallel, I'll also go there. Let me open that. It's a nice little game where you answer some nice questions over there. And what I'm going to do in parallel is I'm going to pull up another page which will basically show us the results of the polls that we are all voting for. All right. So we'll give it about a minute and a half max for everybody to get their votes in. All right, we're starting to see votes trickle in. All right, 100 votes are in. I think we got another, there's at least 200 in here, right? I think. 142, good, okay. All right, 30 seconds and we should walk through the results to see what people think in this room, right? So it doesn't look like many people want to take selfies and post it on social media from initial reaction. Hopefully you can read this. Okay, this is a little better, right? Okay, 176 votes. I think I think this is a pretty good number, right? So the first question was, would you rather be unable to use search engines or social media? As I said, not many people are going to continue to take selfies and post it on social media. So only 10% of the people would, trade it for $1,000, right? 11% now. And then 6% on the search engines, right? Okay. And then would you rather be 10 minutes late or 20 minutes early? 45% of us would like to be right on time, while a good 42% wants to be early. I think being early is good. Is a good sign, right? Permanently 500 years in the future or 500 years in the present, right? In the 21st century, 32% of people think we're good where we are. I personally think this is a very exciting time with all the innovation going on, so that's a good choice. 54% of the people would like to be somewhere in the future. So when I'm thinking self-driving, not even self-driving cars, right? Self-driving planes or whatever, right? Where you can fly by yourself, maybe, right? And then, amazingly fast typing speed versus be able to read ridiculously fast. Interestingly, and I'm seeing this as a pattern in many of my talks where, people do want to read fast, right? I'd argue though, reading fast is one thing and then processing that is another thing, right? So it should really be reading fast and processing it fast enough at the same time, right? So that was a little interesting exercise for all of us, right? I'll get back to my slides. I have a couple of slides and then we'll, go through a demo, right? Right, so what's the high-level architecture? I think Ian spoke about this, right? He said, basically the static content, which is on S3. You've got your API gateway, which is really your front end into all your application and your logic in the back, right? You've got Lambda, which is then going and storing it into DynamoDB, right? Now, of course, you could have RDS, right? You could have EC2 instances, you could have your own API gateway, and you could host the static content or the entire content on a web server, right? If it's a monolithic application, it's usually on a web server, right? So this is the high-level functional view. But as Ian talked about, right, we have to think about many things. We have to think about security. We have to think about scale. We have to think about latency. We have to think about hotkey issues that may arise in your database, right? Because if you're running this across millions of people in a country, then you're going to get millions of votes at the same time, right? It's going to be really high traffic. So how do you handle that, right? So let's talk through the detailed architecture. So you had a browser, right, which is the DNS is hosted on Route 53, and then we have S3 over here and CloudFront, right? What with S3, what I'm doing here is I have configured bucket policies and ACLs. With CloudFront, I've made sure that origin access identity is enabled, so only CloudFront can access S3. So if you were to hit the S3 page directly, you would not be, it'll just say access denied, right? So that way you are basically restricting CloudFront, you're only enabling CloudFront to be able to access S3. Now, if you were running this in a country where you only want citizens of that country to respond, let's say, for example, it's a presidential poll, right? Then you can enable, geo restriction, where you can make sure that only people in a certain area or a certain district or a certain country is able to get in and vote, right? If you have an application that is having multiple pages and you want to carry on, based on signed cookies, then you could use that functionality. If you want to share it with a small number of people, you could use signed URLs. And having it on CloudFront provides you with a lot of DDoS protection as well, right? Now, this is an interesting one over here, right? So, I thought about when I was building this application, I thought, in one of the demos that I was presenting, some people would just hit refresh continuously and they would, continue to vote, right? So in order to be able to authenticate and make sure, this application did not ask you for your username, password, did not ask you to register. You did not have to link it with any social media account, right? So in order to do that, I use an unauthenticated ID so that, I basically store that in DynamoDB, and next time it comes in, I make sure that this user has not already voted, and that's when it'll accept it. So if you were to try to refresh your page and try to go vote again, it'll say, thanks for trying, you already voted though, right? So that's where I'm using Cognito. So that's the first portion is the static layer, the second portion is the dynamic layer, right? Now with Cognito, what I'm doing is I'm getting a token, I'm using that to gain an IAM credential to then use for my API gateway. So if somebody were to directly go and hit API gateway, they cannot use API gateway because that token is missing, right? That credential is missing, right? With API gateway, as Ian talked about, you get a lot of functionality around throttling, around caching. You can monetize it with usage plans, and most of you in this room are partners, right? So if you want to monetize your API, this is your service that you would use. But there is a problem in this architecture, right? if you were to use this across millions of customers and millions of users, how would you make sure that there is no hotkey issues, right? Let's say let's say it's a presidential election, and you're taking a vote or a poll, and one candidate is just famous, right? And all the votes go to him or her, right? How do you prevent and make sure that it doesn't result in a hotkey? And that's why I have this aggregation layer. So hopefully this works, right? What this DynamoDB is storing, all the individual votes, right? So every person, each person will have 4 votes, right? Because you have 4 questions. And this DynamoDB table will store all of that. I've enabled streams, so that way, as soon as a vote comes into DynamoDB, there is a stream that gets pulled off. Lambda is subscribed to that stream. And then what it's doing is it's basically doing an aggregation function right with this Lambda, and it's throwing it into this DynamoDB table. Now the second DynamoDB table, all it has is 16 records, right? 12, right? 3 into 4. So you've got 4 questions, you've got 3 options for each, so you only have 12 options total, right? So that DynamoDB table, all it does is all this Lambda function will do is it goes and increments it by 1. And then you've got your presentation layer, which will that's another simple Lambda function that will package it up and send it to your presentation layer, right? So now with that being said, right, let's go to our console. Hopefully it all works. Okay, we'll start with S3, and I'm sure the session has expired. Okay. So with S3, I have this bucket, which is democlub.xyz, right? And if you look at the bucket policy, as we spoke about it in our, hopefully you guys can see, is it better now? Okay. So what you see over here is I've enabled this bucket. I've put in this bucket policy, which basically makes sure that only CloudFront is able to access it, right? So that's really it. So there's the S3 page. I make sure that only CloudFront can access it, and nobody else from outside can hit that S3 page directly, right? So that's the static layer. And now let's look at CloudFront, right? Let's look at how I've enabled CloudFront. So this is a CloudFront distribution right here, right? And I've set up a behavior over here, right? So you have many options, right? You can redirect HTTP to HTTPS, which is what I'm doing here, or you can just take HTTPS or just HTTPS as well, right? To make it secure, what I've done over here, I just took any HTTP request that comes in, I'm automatically forwarding that to an HTTPS URL for security reasons, right? And if you look at the origin, S3 is the origin over here, right? It creates a bucket policy, and S3 basically is the only one that can access it, right? And I've used all edge locations for best performance, right? All right. So now let's look at Cognito, right? So we talked about why we used Cognito, right? So over here, as you can see, I've used an authenticated role. It's basically assuming a role which will enable it to access API gateway and Lambda and so on and so forth, right? With Cognito, what you could also do, if you are, you can also link it with other authentication providers, right? So you could use your Amazon ID, you could use Facebook, you could use Google, Twitter, whatnot, right? So you could do all of that with Cognito as well, right? And now with this, okay. So here's my API, right, that I've created using API gateway. And as Ian talked about it, right, you've got your gets, you've got your puts, right? You've got your simple methods that you've configured over here. So if you look at my integration request, right, it's basically a Lambda proxy. I'm calling a function called, hopefully, I'm calling a function called cast vote, right, which is basically this first one, right? This first function that's called cast vote, right? And what that function is doing is it's putting individual records in the DynamoDB table, right? So let's look at that Lambda function real quick. I'll walk you through how I'm making sure that users can only vote once and not multiple times, right? So if you look at here, this is simple Lambda code that I wrote in Python. All I'm doing, and this is a really simple Python code, right? I'm initiating a table over here, I'm coming down here and just doing a put item. And if you see, I'm using DynamoDB's in-built expressions, right? Which is one of it is a condition expression. So I'm making sure that this attribute does not exist, right? Before I put the item. So that takes care of all of it, right? In the monolithic world, you would have to, code, right? Make sure you have a query which says, select from this table, see if this user exists, and then that returns a record set, and then you go in and then you perform additional checks, right? With this architecture, you can basically, minimize all of that code because of, you can directly use these libraries, right? So that's Lambda. That's the first Lambda function. Now let's look at the DynamoDB table real quick. So I've got two DynamoDB tables here, right? The first one is for the vote table, right? The actual, okay, let's extend this out a little bit. Okay, so the first one is, for it to capture all of the votes, and the second one is aggregation. So we'll look at the first one, right? Now with the first one, this DynamoDB table, right, it'll continue to grow, right? As I clicked on the wrong one. I clicked on the aggregated one. So this is the vote table. So you see you have you have individual votes stored in here, right? Now what I've enabled over here, over time, if you look at this architecture, right, and you say, well, there are millions of users, there are going to be millions of votes because, each person has so many votes, right, for every question. Now you will run into a situation where you're paying a lot of money because the DynamoDB table is so huge that it ends up costing you more. So what you could do, you could use a function with DynamoDB, it's called TTL, time to live. This basically defines where at what point it'll expire out on its own, right? So as you can see, this one expires November 29th. So I think that's tomorrow, right? It just expires in 24 hours. Now you could keep this if you wanted to, right? If you wanted to do analytics on top of it at a later point in time, or if you want to do some, if there's an audit requirement, then you could use this one, right? So if you look at the structure, really simple structure, right? It's at category 1, which is question 1. The user selected C. For question 2, it selected B, A, C, and so on, right? And this is the TTL. And this is the user ID that we got from Cognito, right? Pretty simple architecture. Now, if you look here, right, there's a trigger enabled over here, right? And that's because you want to make sure that once a record is inserted, it is being captured by the next Lambda function. So let's look at that Lambda function real quick, the second Lambda function. I thought I had Lambda open somewhere. Okay, we'll just open it here. Lambda functions, go to my function. Look at the vote aggregator, right? So this is basically the Lambda function, which is aggregating the votes, right? Oops. Fat fingers. Okay, so all I'm doing here is I'm basically taking them and I'm basically then putting it into the next table, right? So if you look over here, you're saying update item. And the reason I'm not inserting an item, the first time it'll insert an item, the second time around it's going to update the item because all you're doing is you're incrementing the count by 1, right? So that's the second Lambda function which is used in this aggregation layer right here, right? Let's see if there's. And that's really the demo, right? It's a simple architecture, as you can see. It's being built around all of the serverless services. Now, if this was a monolithic architecture, right, then you would, if I start thinking about what I have to do for each of these components, then there's one more, right? Okay. For each of these components, then it's a bigger architecture, right? You've got to think about scaling, you've got to think about security, you've got to think about all these things, right? Here. Let's talk about scaling, right? So with the API gateway, it scales automatically, right? So you really don't have to do anything from a scaling perspective, right? It's designed to handle millions of requests, concurrent requests. Same thing with Lambda as well, right? It's designed to do that. With DynamoDB, it's designed to do that. You can use auto-scaling functionality to automatically increase or decrease the amount of write and read throughput, right? And the same with the other Lambda function and the DynamoDB. So from a scaling aspect, we've completely taken care of this, right? From a security aspect, right, because we are using Cognito and then we are using IAM credentials to assume a role and to be able to authenticate into other services, we are taking care of the security aspect as well, right? And from a cost aspect, because these are serverless services, you don't pay for anything that's not running. So with EC2, although you have great plans with reserved instances and whatnot, right, you'll save a lot of money using that. But still, if the instance is not running, you're still ending up paying for it, right? So with these serverless services are, you're not paying for anything that when it's not running, right? So that's one of our 4 core principles. When we say serverless, we really mean it should be, you shouldn't have to pay for any time that you're not using it. It should be scalable, fault tolerance should be built in, and so on, right? So you've taken care of scale, you've taken care of security, we've taken care of cost as well. And that really is the demo, right? And that's the detailed walkthrough. I'd like to welcome Ian back on stage so we could do Q&A with you guys. Yeah. And I've listed some resources over here. These slides will be posted. I think these are some great resources that you should definitely use. The Lambda deep dive is a really cool one. I think they're all great. The SAM deep dive, Ian talked a little bit about SAM. There's a deep dive on YouTube. I'd encourage you to go look at it. There's a developer tooling. Ian talked a little bit about that as well. There's a serverless page, and there's a nice building your serverless web app, right? That's the first web app that you could build, and essentially, right, it'll give you a walkthrough step by step on how to go about building it, right? We'll take questions. Yes?
2 questions. Do you have this, all the code and everything posted somewhere where we can get to it?
Yeah. The question is, do you have this on GitHub or something? I'm working on it. We'll post it up there.
Second question
yes.
is, briefly, can you describe how the CI/CD piece would work?
Yeah. Do you want to take that?
Yeah, so for the CI/CD piece, so like when he publishes a code, you'll see that this will all be defined in a template. So again, you can commit that to something like code commit or GitHub. And so now I have it in a versionable, auditable fashion. And so when I make those changes to my infrastructure, I can go and push that into my pipeline. So it's using something like Code Pipeline or a third-party partner solution. You can now go through that pipeline. You can have different stages. So it can be triggered when you do your commits, and then you can do something like invoke some testing. You can now deploy it to a staging environment, then do your testing there, and then promote it to prod. So you can kind of define your steps, but through every step you're going to have some sort of provisioning aspect. And so you can use something like CloudFormation to deploy those resources within an AWS account or multiple AWS accounts using something like StackSets or something like that.
Great. Yes? You could use Lambda to do that. So his question is, if I have to consolidate multiple data sources into one and then put it in the aggregator table, can I do that on the API gateway? I think you could do it on the API gateway, but I would say, use Lambda to really process that quickly, put it together, and then send it off to wherever you need to. Right. Or the other option is you could stream it into Kinesis, and then use Kinesis Firehose to send it to S3 or Redshift or wherever you need to, right? That's another option. Yes, somebody else had a, yes?
So basically, if I have the monolithic application, which is our company, right, which is, we are using EC2, of course, right? And we are planning to switch to serverless. And of course, this will be the, we won't be able to turn off the EC2 and start,
Yeah.
From the EC2 to Lambda.
Right.
I don't know, maybe there's some kind of, of course it depends on the application itself. Maybe there are some recommendations how to avoid this spike.
Cost spike?
Yeah, so I guess it kind of depends there. So I mean, if you have, let's say like 100% of your capacity is currently operating on your EC2 instances within your monolithic application, depending on kind of the pieces that you start to pull out, that's going to kind of offset the amount of EC2 usage that you're going to need. And then that would be offset by some of the Lambda usage that's starting to come online. So there's going to be kind of like you said, it's not going to be turn everything off, and then turn everything on. So there's going to be kind of that point where you're slowly transitioning between EC2 and Lambda. And so that's, again, going to come into that design phase where you're determining, what are the pieces that I'm going to pull out. Commonly you'll see customers pull out, specific pieces, specific services, specific components, and that's going to give them the ability to, get more familiar with the process. This is a learning process. It's a lot different from just running an application on EC2 instance versus, okay, now I'm using API Gateway and Lambda, and it's kind of a mind shift. And so we see a lot of customers that'll do kind of a specific piece at a time, and so you can kind of start to proportionally change things. Yes, there might be a little bit of a spike due to the learning curve and depending on the services that you're moving, but you can offset. I wouldn't say it's going to skyrocket. I think there's ways you can kind of architect around that depending on the pieces you're moving at a time.
Yeah, I think one of the keys is to take small pieces, plan it out, start moving it in chunks based on functionality, and then you break it, right? So over time, you will actually see your costs go down because, as you said, right, EC2 costs go down while your serverless, slowly picks up, right? And pay as you go, so it's cheaper, right? Yes.
Maybe some best practices how you can organize your code in Lambda. Should be
Yeah.
like 4 or 5 function or experts, like for example, to work with dynamically, like put, get, and aggregate by data objects, or should we like divide it into separate Lambda function? And
Yeah.
it's actually very hard to.
You talked about SAM a little bit, right?
Yeah, so I mean, you can package multiple functions in one, but again, so it kind of depends on, you can break everything apart into its, a million different pieces, or you can kind of start to aggregate some of those functions together. And it's, I wouldn't say it's a one-size-fits-all, there's a recommendation there. It really kind of depends on your application. I mean, keep in mind, it's one of those things where if this function were to fail and I'm doing 5 operations at once, like, how is my application handling that? Like, am I able to kind of unwind those operations from the previous 3 steps? It's kind of where you see people start to break it apart into different steps because now you kind of have that atomic option where if this thing fails, I don't have to worry about unwinding other pieces. You also get into function duration. If I'm doing a bunch of different things in a single Lambda function, now my functions are very long, so there's some other things that kind of come into play there. So I think it's kind of a give and take between how much you want to, blow everything apart versus, how much do I want to put things together for kind of an ease of use perspective.
I think to add to that, I think one way to look at it on how to break it down, right, is, teams operate autonomously, right? So even within Amazon, teams operate really autonomously. So if you were to, and every team has, multiple code deployments going in. So if you want to, think about breaking your code out based on a function that a team is doing, right, that may be one way to think about it, right, and go about breaking it down, right? Yes, yes.
So we have some data that needs to be stored in the country of origin. What is the best way to handle that in a serverless world?
In the serverless world, what's the best way to handle?
So you can use, like with Route 53, so you can have your architecture set up in a number of different countries based on kind of your requirements. And so you can use something like Route 53 that's going to direct you to the right endpoint. So you can direct it to the correct CloudFront distribution or API Gateway distribution. And then that's going to go through and kind of put you in the right region where you can start storing your data based on the right Dynamo table, S3 bucket, et cetera. So you can kind of use that Route 53 to kind of be that gatekeeper into which region.
Right. And then from a security perspective, we never move data from one region to another region automatically unless you explicitly ask us to do it, right? So it's totally in your control. Data is really yours, right? Awesome. Yes.
It seems like the Lambda functions in this scenario are tightly coupled to the clients. Is there a way to launch a Lambda function, say, from like a message queue or something, so that the clients don't know about the Lambda functions? In this scenario, they were explicitly calling.
Via API gateway, though.
What?
Via the API gateway. It was coupled to the API gateway, not to the front end, right? Yeah, so there are...
The API gateway had to know who's listening. There might be scenarios where you want a Lambda function that the API gateway doesn't know that they're listening.
So your question is, could you trigger a Lambda function from a queue, from message queue, I know that you could trigger it based on, objects that arrive new in S3, or you could.
So yeah, Paras mentioned Kinesis earlier. So you can use something like Kinesis streams.
Oh yeah.
So you can publish that data into a Kinesis stream, and then every 250 milliseconds, based on your batch size that you configure, Lambda can kind of pull those things off. So it's not a one-to-one mapping. You can kind of aggregate those originally by getting, like my batch is like say 100 votes. I can pull those into my Lambda function, do my aggregation there. And that's a benefit there because it could save on your dynamo capacity. You could do batch, kind of aggregate those results, and then you're doing one update item versus one per vote. So like that's kind of the cool part about the serverless architecture is you can do really anything. There's a bunch of different ways you can approach it. You can use like SQS and pull things off there, but then you're kind of manually doing that polling. You can use streams or re-invoke it for you. You can have the one-to-one mapping with API Gateway. You can do some of that stuff with the velocity templates in API Gateway, so your body mappings. So there's kind of a bunch of different ways you can skin the cat there.
Yes.
So as you decouple all these components, do you see problems with things like SAM authentication, federated services for authentication, like on a direct connect synergy?
A direct connect?
Like, you mean like AWS? I mean, you can still use, we're in the partner session. You can use a lot of partner products for kind of your SAML integrations. You can use things, like Okta, but you can do a lot of that stuff with Cognito as well. So the options are there. Are there some complications? Yes. I mean, you have to manage those credentials within your application now. From like the user's perspective, he was doing it with Cognito, but you can still kind of roll your own SAML provider as well. So yeah, I mean, there's a bunch of options there, AWS or, what's that? I don't think we really have
user synchronization approach. Okay.
We can chat after if you'd like.
We'll chat a little more in detail to understand the use case, and then we'll come up with the architecture. Yeah. Oh, yeah.
Good.
Is there any way in console, not by using AWS and local, to point the same API gateway request to the particular Lambda function method?
I'm sorry, I'm not following.
Point API gateway request
Yep.
to the particular Lambda function export. If you have three exports in one Lambda, is there any way to point it by using console, not using the same local?
Oh, you're saying any other way apart from the console instead of SAM. So you could use SAM templates that Ian talked about, right? You can basically define, where you.
But if you're using console, without the SAM template.
So a Lambda function, and I may be misunderstanding your question, I'm sorry, but like when you define your Lambda function and you have your export, so I'm assuming you're using like Node.js or something, you have your handler and you specify what that entry point is. And so the Lambda function is always going to go that one because it's configured at a function level, not like a...
But you can use multiple handlers.
Correct. Yeah. So we're doing an application similar, so game day, we're using the same thing. We have, like 30 different exports in the same Lambda function, so we have the same deployment package. We just have different functions that have different entry points. So the Lambda zip file is the same for all those functions, but we're just telling the Lambda function, this is this function, this is your handler, this is this function, this is your handler. So we've kind of separated it at a function level, even though it's still the same code, it's still the same, JavaScript file all within it.
Select the particular function inside.
Oh, inside the Lambda.
Yeah, you can't specify a specific handler. You specify the Lambda function, and the Lambda function specifies a specific export.
Yeah.
And then pick up what type of the
Right.
request. There's no way to point it in the API gateway.
Directly to a function.
The only way you could possibly do that is to have, one main handler in your Lambda function, and that's basically like your router handler in there. And so then you could kind of invoke the correct method within that.
Right.
Yeah.
Okay. Yes.
So I know one of the big problems we've had in going to some of the serverless stuff, especially like managed stuff like the pieces, is you're looking at like a 40 millisecond response time sometimes back and forth between EC2. How is that between Lambda functions? Is that better than it used to be? Worse? Can you ping things so that you can stick in that 2 millisecond response time that you generally get from EC2s in the same millisecond?
So you could run your Lambda functions in a VPC, which you could kind of scope it down, but then you're going to pay the penalty because the Lambda function in a VPC is using an ENI. So I think that would kind of nullify that.
You could use X-ray to basically see how much time it's taking, right?
Yeah, you could use X-ray to see the monitoring aspect. But yeah, I think the only way to really determine and nail it down would be to kind of run those tests internally to have maybe a host that you have in a VPC, and then you kind of test it if you're running it in your VPC to kind of get those metrics yourselves. I don't have those metrics. We could possibly chat about it afterwards to see if there's something we could do. Lambda team's here, so it's a cool question we could ask.
I think we can dive deeper into that. Yeah.
So we can talk about Lambda functions, right, as the handlers. So how about using the stepper functions? Actually, probably it will be the same pattern, just the stepper functions will be implemented in some kind of workflow. And actually, the question is, are people using the stepper function? Because it wasn't like we introduced last year, I believe.
Step functions?
The response of the crowd about the stepper functions.
Separate step functions. Okay. How's the response on step functions?
Yeah, step functions has been huge. A lot of people have loved it. So we still do have the simple workflow service, which kind of gives you that ability to have that state machine, but it just wasn't one of the kind of the really heavily used services. And so step functions was kind of a way to, combine both, okay, we know people are using Lambda functions, we know people love the serverless, kind of world, but they need a way to stitch these things together. And so that's where step functions has really kind of shined, and we're using it in-game to do things like, we have a whole account provisioning process, and so there's like 30 different steps in there. We're using organizations to go through, and so previously we would stitch these together by hand, where we'd have a Lambda function, and then we'd go through and execute, invoke another Lambda function. So you can kind of, have these, daisy chain Lambda functions, but it was very nasty, and it didn't really we didn't have any error handling if we took a step back. So like, what if these Lambda functions fails? We don't have a way to really catch that. We don't have a way to invoke another function that's further downstream. And so that's kind of where step functions shines, because you have kind of that orchestration level that's above it. So you can do things like raise exceptions and then catch those errors, and then, kind of slipstream chutes and ladders to another step within it. So it's gotten a lot of traction. There's a lot of things that really benefit you, especially if you go towards the serverless model.
Yeah, I've seen customers use step functions pretty extensively when they have multiple things to perform. Right.
Yeah.
Can you talk a little bit more about some of the pitfalls that customers are facing when they migrate from Monolithic architecture to serverless?
Yeah.
Like the whole stars that are not there easy to do and other limitations.
Yeah, one of the things I've seen is underestimating the amount of time it will take to decouple some of these components, right? So oftentimes we think it's going to take 2 weeks or 3 weeks to decouple this entire functionality. But what sometimes customers do miss out on is to make sure that all the dependencies are also taken care of. So that's definitely one thing that you should think about. The other thing is, from a performance standpoint, right? You want to do an end-to-end testing, right? You want to do a system test, you want to do an integration test, you want to make sure that from a usability perspective, it should be better than, or it should be same or better than what you already had. So those are a couple of, performance is one that often sometimes people forget. The read-write throughput that we talked about, over time, once you see the traffic spike, sometimes you get throttled back, right? So you want to make sure that you've got enough read-write throughput provision, or you turn on auto scaling, right? So those are a couple of broad areas where I've seen customers sometimes it's like a blind spot, right? Sometimes they just don't see it, and then they realize over time. So those are some couple of things, and then on the project management side. You want to plan it out. You want to phase these things out, over time, so to make sure that every individual component is fully tested, fully integrated, fully ready, while you are working the other ones, right? So you could have parallel teams working on multiple areas, right? So that's when integration testing becomes all the more important, right? So definitely say those are top 3 things. Ian, do you have any other things that come to mind?
No, I think that, it really comes down to when you go to the microservices and serverless approach, you really kind of have to fully adopt it. So you really want to kind of reduce those dependencies between the components. So, by shoving similar things into the same Lambda function, you really haven't gained yourself anything, because now if one service fails, you're now affecting other services, because you want to have kind of that clean, logical, physical separation between things. And so we see people kind of doing that halfway point, by not fully separating things out, because maybe there are some dependencies. Maybe I'm kind of always used to this service being there and being able to talk to that service instead of funneling everything through a central API. So kind of doing that halfway approach where you're still kind of in the monolithic camp, but you're using serverless, so you don't really get the benefits of it. And so that kind of gives it, not the best experience because you haven't really given it the full shot. I'd say that's kind of one of the common things we see.
And then make sure that you shut down those instances that were running those, the monolithic application, right? So because your costs will go up otherwise. Your costs will continue to stay up. So shut it down so you're not paying for it. All right, I think we are right at time. So thank you very much for coming. It was a pleasure talking to you all, and I hope you have a great re:Invent conference. Thank you.
Enjoy the rest of your week. Thanks, guys.